Hi dear students, today we are going to discuss a question. What is iterated here? You can observe that 1 plus sin phi plus का iota times of cos phi upon में 1 plus sin phi minus का iota cos phi to the power n, okay, is equal to, we have to prove this, okay. But before proving this, I am going to tell you some results. So we will use that result to prove this question. Okay, let's show some results. We'll use the results. There are some basic results what you all know, so I'm not writing that. I hope you all know the formula of this, that is a square plus ka b square plus ka 2ab. We will use this result, and we will also use this result, a square minus b square is equal to a square, and sorry, a square plus ka, sorry, not a square, only a, sorry, a plus b and a minus b. So we have a, okay, we have a plus ka b into a minus ka b. This is second result. And third result, I'm going to use that e to the power iota theta. Do you know what we write? This is a complex, okay? This is a polar form, and it's a Cartesian form is written as the cos theta plus ka iota times of sin theta. Okay, this is the third formula what we use. And also use the De Moivre's theorem. I hope you all remember De Moivre's theorem, in which we have cos theta plus iota sin theta to the power n is equal to cos n theta plus ka iota sin n theta. Okay, actually I have not used this anyway, but I am telling you because you can also use this result to some of its part. Okay, आगे हम बताएंगे किस तरह यूज होगा. चलिए अभी स्टार्ट करते हैं, ठीक है. So here I have taken the left hand side what we have given in the question. So what I have done, I have rationalized this part. Okay, the denominator has been rationalized here. So I have just multiplied in the numerator part, in the denominator part by positive terms of this. Okay, I have multiplied. When we multiply, what we get? You can observe that there is nothing but a plus ka b form, a plus ka b form. So here we have a plus b ka whole square in this case, and the square by after squaring this, what we get? You can observe that we get 1 plus sin phi and plus ka iota cos phi to the whole square. And I hope you all know this formula what I have previously told you also, and you can observe here written. So we have to use that formula, just a square, that is here a square plus ka b square. The square of this part is what? Means that iota square is also included. When you take the iota square, at the value of iota square is minus 1. Okay, that's why here we get minus ka cos square phi. And after that what? 2ab part. 2ab part means what? 2 times of this part into this part. So we have 2 iota cos phi sin 1 plus sin phi. Okay. And in the denominator part, we use the formula a square minus b square. You can observe that this is our a part, this is the b part. Here we have a minus b, and here we have a and plus ka b part. Okay. When you multiply both the part using this result, we get a square minus ka b square. Okay. Where a is 1 plus sin phi and b is iota times of cos phi. So after squaring that, what do you get? I am going to solve this here because next time in the next page I will use the value of this. So I am solving here. Just square 1 plus sin phi. So we get 1 plus ka sin square phi plus ka 2 sin phi, no problem. And here when you square iota cos phi, we get minus ka cos phi, and here we have also 1 minus. So we get addition ka sin square, sorry, cos square phi. So when you add cos square phi and sin square phi, we get plus ka 1. So 1, we get 1, and plus when we add this and this, we get plus ka 1 and plus ka 2 sin phi. So overall what we get? 2 plus ka 2 sin phi. So when we take 2 as the common, we get 1 plus ka sin phi. Okay. So in place of this value, okay, in place of this value. Now I will use 2 times of 1 plus sin phi. You can observe how we have just exchange, or you can say that transformed, or we can say that simplify this value into this form. So let's move ahead onto the next page. You can observe that I have just separated all the values. I mean separated this value with 1 plus this term. Here you can observe the first term is separated by this term. Okay, second term is separated by 2 times of this term, and third term is also separated by this term. Okay, by the result what we have previously solved here. Now you can observe that 1 power of 1 plus sin phi will cancel out, and after cancelling out its 1 power, what we have? We have 1 plus ka sin phi in the numerator part and division into 2 divided by 2. Okay, तो division हो रहा है. So we will just separate it also. जैसे हम इसको separate करेंगे, we get 1 by 2 one times, and second time we will separate it by 2 again. This part, तो हमसे फिर से हमें क्या मिल जाएगा? Sin phi by 2. So we have written this into this form. And now you can observe that we are again rationalizing this function. 1 plus sine phi is in the denominator part. So I'm rationalizing here. You can observe we have minus ka cos square phi. I'm multiplying numerator and denominator by 1 minus ka sine phi, because we have in the denominator part is 1 plus ka sine phi. So multiplied by 1 minus ka sine phi in the numerator, and in the denominator part also denominator. So we have 1 plus ka sine phi or 1 plus minus ka sine phi. Okay, when you multiply, we will use again that rule, a plus b, a minus b. We get a square minus b square formula. So here a square is 1 minus ka sine square phi, and in the numerator part we have 1 minus ka sine phi. Okay, here so we have 1 minus ka sine phi. You can observe that, as I guess you all remember the formula of sine square theta plus ka cos square theta is equal to 1. So value of cos square theta will be what? Or you can just observe that cos square theta will be nothing but 1 minus ka sine square phi, sine square theta. So I have just replaced this value by the cos square phi. When you replace this value by cos square phi, this cos square phi and this value will get cancelled out. So I have just removed this value from here. So what will remain? Minus times of 1 upon 2 and 1 plus ka sine phi. So just open this bracket. So we get minus ka 1 by 2. When we multiply this 1 by 2 to this one part, and again this minus will multiply to this minus, we get plus sine phi by 2. Okay, and this part is written as it is. So again, you can just observe that this half will get cancelled out, and when you add half part of sine phi here and half part of sine phi here, you get 1 times of sine phi and another times of cos phi to the power n. Okay, now this inside part of the bracket can be written in the form of this also. You can observe, because the cos phi is 0, 0 into cos phi will be 0. This term is 0, and again here sine pi is 1. 1 into sine phi is sine phi. Okay, and here plus ka iota times of, you observe sine pi by 2 is again 1 into cos phi. So here in the part of first part is cos phi, and again cos pi will be 0. So second part is 0. So you can observe that we have nothing but it's the same what we have in the previous slide. This is the same result. Sine phi iota cos phi. When you observe, this is the same. Here we have sine phi part, because this is a 0, this part is 0. It is meaningless, and this part is nothing but sine phi plus iota times of, here we have only this part is cos phi, this part is again 0. So we have the same things what we have in the previous slide. So we have just rewritten in the form of this. Why we have rewritten in the form of this? This question may arise in your mind, because we want to convert this into the form of cos theta plus ka iota sine theta. I want to convert the obtained this equation, what we have obtained. I want to convert this in the form of this. Okay, to convert into this form, we are making some changes. Okay, that means we are taking some addition and subtraction parts. So after that, you can observe this is nothing but what? Cos pi by 2 minus theta. I hope you all remember the cos a minus b formula. So this is nothing but the same formula of cos pi by 2 minus ka phi. And again, this is nothing but a cos pi by 2 minus ka phi. So we have just rewritten this as in the form of this, and this one in the form of cos pi by 2 minus ka phi pattern. And after that, what I have told you in the first slide, that's e की power iota theta wala formula. Okay, we have just used that formula to transform this result I mean inside the bracket, excluding the n part. This can be written in the form of this, because in place of theta we have this value. You can just observe what I have written in the first slide, very first slide. That was e की power iota theta was nothing but this value. Okay, when we have here is a theta, so I can see that this into the form of polar form. It is for iota theta. And in the question where we were last time, you can observe here that this is in place of theta we have only pi by 2. So I have just replaced here in place of theta pi by 2, because here we have both the values pi by 2. When you compare both the results, you get that this is the result we have obtained, and this is, and here we have also power n. So we have put it here power n. Okay. Now when you take n is, because n is in the power of this, when you take this n inside, we get n is multiplied with the pi by 2 and phi also. So we have multiplied that, and we have rewritten this into the form of a cos and sine. So we get this result, what is desired result. You can also use from here directly the de Moivre's theorem. From here directly, if you use the de Moivre's theorem, you can again directly get this result also. I have just converted to the polar form, and again I use the result of n power and then converted this into the cos phi and sine phi. Okay, sine pattern. That's all for today. You can observe that it is right hand side ke equal aa gaya. That's all for today. We have proved this result. That's all. Have a good day. Bye bye.